Hi everybody, and welcome to Pythian's webinar series. My name is Alexandria Hodson, and I'm the Microsoft Partner Manager at Pythian. Today we have Pythian's Microsoft MVP with us, Warner Chaves. And for the next 60 minutes, Warner will be covering the topic of migrating your database to SQL Server 2016. Please feel free to direct any questions you have today to the question box, and we will be happy to answer them. Over to you, Warner.
Hey, thanks, Ali, and welcome everybody to our webinar for today. We're going to talk about migrating your current database to SQL Server 2016. So let's get started. Allow me to introduce myself first. My name is Warner Chaves. I've been a DBA and consultant for Microsoft Data Platform for 11 years at this point. I used to work out of HP in Costa Rica as a level 3 DBA, but I've been at Pythian now for quite a while, and I work out of Ottawa, Ontario. If you want to reach out to me on Twitter, feel free to do that at warchav. If you also want to check out our company website, especially our technical blog, has tons of really good material. Just make sure you pay us a visit at pythian.com. All right. So, goal for today is we're going to discuss the motivations, methodology, and I'm going to give you guys a small demo of the migration assistant to migrate an Oracle database workload to SQL Server. Now, in this case, the example is going to be Oracle to SQL Server. However, the motivations, the features that are really compelling for migrating from SQL Server, the dilemma of whether on-premises or cloud, the migration methodology, and even the migration assistant. Microsoft has different migration assistants. For example, there's a migration assistant from DB2, there's a migration assistant from MySQL. So even though, like I said, the example is going to be specifically for Oracle, a lot of these same concepts and ideas would apply regardless of whatever platform that you are migrating to Microsoft SQL Server. Okay. So let's get started here. First, let's talk about what usually happens and why customers sometimes find themselves supporting or maintaining or renewing licensing costs on systems that can end up not giving them really a good return of investment. So first of all, a lot of Oracle-based applications were just developed with Oracle because it was what was available at the time, and they're not even actually using a lot of Oracle exclusive features, right? So back when that choice of platform was done, it wasn't really a choice that was based on a cost-benefit analysis. It was just based on what was available. Also, there's a history there between how SQL Server has matured into a product where for a long period of time SQL Server wasn't seen as a mission-critical database engine, right? And there was a big gap in functionality between Oracle and SQL Server. Now, this gap has dramatically closed in the last few years, and there are mission-critical and very revenue-generating workloads that run on SQL Server every single day. Right, so like I said, the difference between the two database engines have definitely narrowed, where we can now really realistically look at them and do a migration from Oracle to SQL Server by taking really into account the features that we're really using and the cost benefit, instead of just, you know, we picked Oracle and stayed with Oracle because of non-functional reasons, right? Because of what was, you know, that's what we used in the past, or that's what we were comfortable with, and we just don't want to change what's not broken, kind of thing. But obviously, there's a cost to staying, right? It's a sunk cost to believe that we should just stay on a platform, even though we might not be getting a return of investment for the cost. Okay. So what motivates a platform migration? If you are in Oracle and you are not in Oracle for functional reasons, then what is the reason why you would want to think about doing a platform migration? Well, number one thing that we see is supportability. It is still a very complex product, and they have worked, it's true, they have made efforts to simplify it, especially trying to do easier things or making it easier for the cloud. But at the end of the day, it still requires expert skills support, and Oracle is still pretty much lagging, you know, behind Microsoft, where Azure sits in the market and it sits in terms of functionality. Patching is getting better for Oracle as well, but it's still fairly difficult and time-consuming when we compare to how trivial it is to be done on SQL Server. And then the support tools, they don't have specifically a cost, but they do need more consistency in operation. Sometimes a parameter will do something differently on a different tool, even though they're both come from Oracle, or they have slightly different names and so on. So they definitely don't make it as easy as it is to work with the tools, as opposed to, most DBAs on SQL Server are very comfortable using Management Studio, for example, and they can do 90% of their tasks with Management Studio or just with T-SQL inside Management Studio as well, where they have the full support of IntelliSense and so on. And then obviously the biggest factor is cost, right? It's not a lie or a secret that Oracle is more expensive than SQL Server. I don't think that's debatable or controversial, really. The fact is are you getting the return of investment for that cost, right? Because there is a capital cost. You have to acquire the software, you have to support it. There is the total cost of ownership, where you obviously need your resources to actually run it and maintain it, and you also need to have that paid support, which is not an optional thing in the Oracle world. And what we find is that sometimes the cost becomes so prohibitive that clients just start running without support or without any third-party support for their Oracle engine, even though that puts them at a high-risk situation. So when you find yourself in a position where, due to cost, you simply can't continue to have that support for a mission-critical system, I would say it's probably a good time to stop and consider if there's a way to migrate your way out of this type of situation. Something that's a big factor as well is Oracle's licensing is, again, knowingly a lot more complex than SQL Server, and it does produce a lot of customer anxiety that they're going to get audited and they're going to end up owing Oracle quite a bit more money than they thought. Remember that it's not like SQL Server, where there's only 2 editions and everything comes baked into the Enterprise Edition. There's a lot of features inside Oracle that you have to license separately, such as like partitioning, for example. And what this does, obviously, is that sometimes the client starts to use a feature that they were not already licensed for. Once it's time for the audit, then Oracle discovers that the client was using this feature, and the client has to come up with the money for this feature that they somehow enabled. And maybe it was even not enabled by a developer that didn't know that this feature had an extra added cost. And these prices are per core, right? So if we're talking about you had a 32 core server where somebody decided to enable partitioning, now you have to pay the licensing for partitioning, the cost for partitioning licensing times 32, right? And there's another factor here of cost that is just Oracle has made a couple of moves lately that are just non-consumer friendly. For example, they just published recently licensing cost changes if you run on a non-Oracle cloud. So if you run on AWS or Azure, the licensing cost and even the features that you can deploy on both of those are different than if you want to deploy it on the Oracle cloud. So it doesn't seem like it's technically motivated. It just seems like it's a business decision to limit clients in this way. And it's the same with running on non-Oracle virtualization, where we're still, here at Pythian, we have very talented Oracle consultants, and sometimes there's still debates on, oh, this should be licensed this way or this should be licensed the other way, just because there is no clear guidance, and the documentation or the actual terms seem to be kind of ambiguous on purpose, so that they can just be interpreted differently by whoever is auditing you. Right? So some people might think about the supportability argument. They might consider the cost argument. They might still not be quite convinced that they should embark on a migration project, even after considering those 2 factors. And here's are some of the common arguments that we do hear out there in the field when we pitch these ideas. So first one is classic thing that people would say is that they challenge the technical merit of migrating out of Oracle, right? So, and agreed, we know that Oracle is a rich product with many features, but a lot of it is gated by being on Enterprise Edition And on top of that, it's gated by licensing all of these optional add-ons, like I mentioned, partitioning, for example, compression, spatial capabilities, right? So true, you have all these features that could be very rich, but you have to pay multiple gates of licensing to get access to them. And a lot of the time, the client will say, yeah, but we can't migrate off because Oracle is a really rich product and has all these features. But when we actually look at it, the client is not really licensing those features or is not even using them. They just like to think that they have the potential to use those features. And like I said, SQL Server has narrowed that gap dramatically, where 99% of the times we are able to come up with either an equivalent feature or an equivalent compromise to the client requirements. So let's see, for example, the difference here in how both companies approach their install base. Whereas we were talking about all the features that are gated in Enterprise Edition and that on top of that are gated by optional licensing packs, Microsoft just late last year when they released SQL 2016 Service Pack 1, they made a lot of features available on Standard Edition that for many years had been exclusive of Enterprise Edition. So there's more than this, but this is like the top ones that I could fit in a slide. And we can see things like partitioning, data compression, column store, in-memory OLTP, database snapshots, change data capture. These are truly advanced features that are now available on SQL Server on Standard Edition. So we're talking about a product that could be $1,500 to $1,700 per core, coming with partitioning, with columnar technology. There's truly no comparison in this regards as to what you get with a SQL Server standard install compared to what you get with the Oracle standard install. And like I said, different licensing gates that you would have to go through to get access, for example, to partitioning on Oracle, right? Because it's not just, you can't have Oracle standard and then buy partitioning for it. You need to go to Enterprise and then you can buy partitioning for it. So completely different strategies for both companies. And I think a lot of clients are starting to recognize and appreciate the difference in approach. Another common counter argument is that the client doesn't want to be on a Windows solution, right? And this is another one of those where it's more of a historical reason of why this argument comes up other than actual technical merit, right? In the past, Windows Server has been perceived as a higher vulnerability product that required a lot more management to make sure that you would be up to date on all the patching and so on. Nowadays, it is the way you install Windows servers is, secure by default, and then you enable what you want to enable and you open what you want to open. There is also the options to deploy Windows Server, for example, Windows Core, which has a way smaller surface area for patching, and that you can do all the management remotely. There's no interface, so you don't have to worry about patching things for audio or video drivers or anything like that. And more interestingly, though, the argument of we don't want a Windows-based solution is has lost all validity now, because Microsoft has announced that they're going to put SQL Server on Linux. So for the few people that are not aware of this development, so SQL Server on Linux is targeted to come out later on this year, and it is going to be a feature parity version. So everything that you get on the Windows version, Microsoft is targeting to release it on the Linux version. And it is going to be 100% supported, and most likely it looks like right now it's going to be Red Hat Enterprise Linux, CentOS, Ubuntu, the ones that are going to support the strongest. So the whole argument of, we don't want to promote a Windows solution, or we don't like a Windows solution, at least in terms of database engine, is actually completely mute, or will be completely mute by the end of this year once SQL Server is released on Linux. Okay, another argument that we hear all the time as well is that, well, there is no actual parity because Oracle has some really unique technology that there's just simply no equivalent on the Microsoft stack. So some of the engineered systems or the architectures like RAC, our usual counter argument is that there are very few cases where those actual solutions are really the requirement and the client couldn't live without them. A lot of the times, yes, those solutions have been deployed, but you know, maybe they wouldn't have been necessary if the solution itself had been fully optimized. Keep in mind, Microsoft has fast-tracked architectures on modern commodity hardwares from commodity vendors such as Lenovo, Dell, HP, etc. And you can download the fast-track architecture. You can download and when you download one of those fast-track sheets, it comes with the sizes of the database that they tested. They come with if they did like a TPC test on it, and they show how fast the benchmark went and so on. On the other hand, if you want to run a stamped accepted architecture from Oracle, it's always on Oracle hardware. So you're kind of locked in both your vendor and your software vendor if you want to go with an Oracle approved architecture. And like I mentioned, on the other hand, Microsoft gives you the choice of vendor for the hardware piece, and then you get your software from them as well, right? So you're not locked in 100% to the same vendor in this case. And what we found is that on most deployments of these other technologies, there is an acceptable solution that can be done on modern commodity hardware with SQL Server nowadays. So let's assume, like I said, that the arguments are good in terms of support, in terms of cost, in terms of debating the counter arguments about the uniqueness of the technology, about not being locked into a Windows solution. So why select SQL Server? Why specifically SQL Server? Why not go to any other database engine that is out there in the market? Well, first, I think one of the big drivers of SQL adoption is that when you buy SQL Server, you get a complete solution. You're not just buying a database engine and then you have to piecemeal buy all these other features and all these other tools and all this other functionality, right? So if we're talking about somebody buying SQL today, you would get the database engine, you would get SQL replication features, including all the type of replications like merge or transactional replication or snapshot replication. If you were to buy enterprise, you would get also peer-to-peer replication. You get an ETL tool when you buy SQL Server, right? You get SSIS. You get a reporting server, which is also being augmented right now to be even more powerful by adding the capability to do Power BI reports inside reporting services. And this is also targeted to be released by the end of this year. You get an online analytics server with analysis services, which nowadays supports both the classic cube multidimensional model and the in-memory tabular model. And you don't only get those really core services, you also nowadays get some things like master data services, which is a data governance tool. You get data quality services, which help you with data quality issues. You get distributed replay, which is the tool to split off replays of database activity for testing. So at the end of the day, not only does it include all these things, but it's also simpler licensing with not as many product versions. And so it's very simple to tell, what you're buying. And if you bought something, you don't have to be afraid that when the time comes to the audit, you might be using a feature that you were not licensed for, right? If you try to enable a feature on standard edition that is not available, like let's say for example availability groups, and you try to make a read-only replica in standard edition, which you can't do, it's not going to let you, and that's it. It's not like it's going to let you and then when the time of the audit comes, suddenly you have to pay up because you use that feature, right? So a lot simpler and not prone to mistakes like that. Next, we have to also recognize, like I said, that not only has the feature gap narrowed between SQL Server and most other database engines in the market, but it has actually taken the lead on some very interesting points. So nowadays, SQL Server comes in with a columnar engine, right? So we're talking about technology that used to be available only on very expensive data warehousing systems and is now available on SQL Server on Standard Edition nonetheless. And with batch mode, which is truly unique to SQL Server, the capability to just process multiple rows through the CPU at once, and makes performance blazing fast when we're working with columnar and column store indexes. We also have the in-memory transactional engine for OLTP workloads. So this is not just, a lot of people thought it was like, oh, it's like pinning your table to memory. Like if I already have a server with memory, I can already do that. No, it's not that at all. It is truly a separate engine that has algorithms that are all optimized and assume that the records are in memory for, the maximum speed that you can get, basically. And again, available on Standard Edition. Nowadays, there's built-in JSON support, so there was a gap here before 2016 where SQL Server was not providing built-in JSON support. That has been narrowed. They have done a lot of development with security and released some really nice new features in 2016, like dynamic data masking, where we can set masking rules on sensitive data, always encrypted, where we can encrypt information and the decryption key is on the client application server. So not even the DBA can look at the encrypted fields. And also row-level security for truly granular security profiles if it's necessary. And keep in mind as well, Microsoft continues to do huge investments on Azure, right? So the fact that Microsoft both owns SQL Server and Azure allows them to build really cool cloud integrations, such as, backup to URL. So you have a native T-SQL command that will back up directly to the cloud, or things like the new 2016 stretch table storage. So a very cool idea where you can actually enable your table to stretch from wherever it is, either on premises or running on SQL IS in the cloud, in any cloud really. And from there, stretch to Azure storage, right? So if you're thinking, I want to provide archiving for this table, and I also want to make it available for people to query in a transparent way, well, you can do that with stretch table, right? So very cool cloud integrations, and I'm sure that it's not going to be the last ones that they develop. They're going to continue investing on these cloud integrations to make sure that the SQL Server and Azure mix and story continues to be strong and a good driver for people to really see SQL Server as a modern product that will allow them to scale into the cloud as well. Now, another good choice and something that we need to consider is if you do decide that you want to go to SQL Server is, well, do you want to do it on premises or in the cloud? And this is another point where SQL Server truly provides a degree of freedom that is hard to find in other products, because you do not only get SQL Server. Nowadays, I would call it's like the Microsoft Data Platform relational family of products. So you have the choice if you want to do SQL physical or do it virtualized. If you want to go private cloud, if you go virtualized on Hyper-V or VMware and you want to go private cloud, or if you want to do public cloud, you can do AWS, Azure, GCP, because even Google nowadays is providing SQL images, and Google just recently also provided a documentation about doing availability groups. So again, the product itself is friendly to all these other clouds. We're not talking like the non-consumer friendly policies, like I mentioned before, of some other vendors. On top of the choice of physical or virtual, private or public, Now we're going to get the extra choice of operating system. So you're going to be able to decide if you do like and you're comfortable with running Windows Server environments, then you can just keep doing what you've always been doing. If you want to do a move to Linux, or if you had always been a Linux shop and wouldn't deploy or consider SQL Server because of that, well, now you're going to have no longer have that excuse to not consider SQL Server, since we are going to put it on Linux as well, right? And we do expect that we're going to get quite a bit of interest from clients on exploring those options. If you are going to the cloud, then if you're not only going to IaaS, you can also go to some of the offerings that are platform as a service in Azure, so just Azure SQL Database, which again has narrowed the gap on features and functionality that is not available from Azure SQL Database that is equivalent to SQL Server. And we also have really cool features in Azure SQL Database like elastic database pools that truly take advantage of the elasticity of the cloud, where you can take a group of databases and increase the amount of compute power that you give them at a certain amount of the time of the day, and then bring it down when they're on like lower activity, and then get some savings from doing that kind of stuff. If you do want to move also, if let's say you evolve from your SQL Server SMP and you want to try MPP data warehousing, which is a big deal nowadays with all these products. I mean, Teradata has been doing it for a very long time. We have Oracle Exadata as well as the on-premises data warehouse MPP. Microsoft has SQL Server's PDW, which is now bundled into the Microsoft Analytics platform system. So if you do want to evolve from your SMP SQL Server into an on-premises MPP data warehouse, well, that's a path that you have. Or even easier, in my opinion, is if you want to evolve from SQL Server SMP to an MPP data warehouse in the cloud. Nowadays we have Azure SQL Data Warehouse, right? And this is an offering obviously very tempting because data type compatibility is very easy. It supports T-SQL, so you don't really need to learn anything new, and it comes built in with the same column store technology that you would be familiar with SQL Server. So a very natural progression for people to simply say, I'll start with a SQL Server investment, and then if I want to move to PaaS, we have Azure SQL Database, or if I want to move to an MPP data warehouse solution down the line, well, there's options for on-prem, and there's also the option for Azure SQL Data Warehouse in the cloud. Okay. So what does a typical migration look like? So when we take on these projects, what are we talking about in terms of effort and what we do? So there's some usual challenges that can come up if we do an Oracle migration. It really depends on what the client has used, on the complexity of the schema and the data types the client has picked. These are all really big factors in what type of challenges can come up. For example, if they're using complex data types like binary data, we need to figure out what was it that they were storing in binary and figure out how we can convert it and keep the same definition or keep the same meaning when we move it to SQL Server. If the client has implemented some custom data types, if they have implemented some Oracle-only features like nested tables, which are not truly relational and things like this. If they're doing external calls, well, obviously every time that you're doing an interaction with the operating system, you're adding an external dependency to your database, so those things will need to be analyzed and again figure out if there's a way to port a similar behavior over. If the client has done a large PL SQL investment on many things that are proprietary to PL SQL, so it really depends on the complexity of the procedures, of the functions, of the packages, of the types that they're using, like I mentioned, or the triggers, and all this has to be analyzed to be able to determine the complexity of how big the migration can be. And there are tools for it, and like I said, I'm going to demo in a few minutes the migration tool from Microsoft. But that it would be, it's not true that 100% of the times you're only going to need the tool and that's it. Some cases you'll have the challenge that you'll need some actual manual intervention after you've applied the tool. So depending on complexity, the tool might be a first step to get a first, let's say, draft of your migration, what will look like, and then you will need some expertise either on the Oracle side or on the SQL Server side to bridge the gap of what the tool wasn't able to do. And similarly, depending on what type of business and how important the Oracle system is to the client, we might have different requirements for how long the migration can take or how much downtime we can take to migrate them from Oracle to SQL Server. So if it's not as simple as just, we're taking a big maintenance window and then we're transferring all the data at once, then we need to think of something else. Then we're going to have to think of, let's say, are we going to build a custom SSIS package that will run, let's say, every 10 minutes to sync Oracle with SQL Server? Or are we going to use something else like Oracle Change Data Capture to try to capture everything that's happening on the Oracle side and apply it to SQL Server? Or are we going to use maybe a third-party utility that can do heterogeneous replication from Oracle to SQL? So all those are options that we consider with the clients, and then we determine what the best course of action depending on the client requirements, budget, effort, and so on. Our migration process it's really a collaborative process. So we do work closely with the application teams because we want to analyze what are the features that are truly, let's say, more complex to migrate from one to the other, and we have to create a migration path for the specific scenario. And truly every environment it's individual on its own and has different characteristics. So usually these migration paths all have to be custom made depending on the client and what they have invested in and what features they're using and so on. We do leverage the Microsoft Oracle Migration Assistant, and like I mentioned at the beginning, this is just one of the migration assistants. Microsoft provides migration assistants for other platforms like DB2 and MySQL, for example. I believe there's also a Sybase one. And that tool really can kickstart you for the analysis and code conversion. Like I said, depending on complexity, the tool might not be the end of the process, right? So you do have to be ready to roll your sleeves up and do some of the work. But the tool can actually help you at least, like, get off the ground and start running with a rough first draft. And finally, obviously, the big piece of the migration is we have to test data migration, make sure that it actually will move without problems. We have to make sure that it does not lose any data, of course, and we have to do any code refactoring as necessary, either because the migration assistant wasn't able to automatically translate it, or because there are some features that we need to adopt from one to the other, and it's beyond the migration assistant scope, let's say. So this is typically what our timeline would look. At first, we do the analysis, phase one that you see right here. We do the analysis and planning with the client. In this case, we're talking about identifying those features of Oracle, identifying that SLA that we have for downtime, identifying any type of external dependencies and so on, like I mentioned. Phase two, what we usually do is we will do a proof of concept with the client. And based on the results of that proof of concept, so we'll do probably like a one-shot migration and code, and then do some application testing to make sure that, yes, prove that it's possible and that we can get good performance as well and not lose functionality. Once we have those results, we create a roadmap for the next phases, right? So we do a phase 3 of a build. That's when we set up the infrastructure, whatever it is. It could be SQL on-prem, it could be SQL on IaaS on a cloud provider, it could be Azure SQL Database, it could be Azure SQL Data Warehouse. Once that's built, we can actually move forward with migration. That's where we leverage what we learned in phase 2 while we did the proof of concept, and also we leverage what we learned on phase 1 in terms of downtime and SLA requirements. We apply those on phase 4 for migration. And then finally on phase 5, it's an optimization stage to make sure that the SQL Server solution will perform the same or better than the previous Oracle solution. Okay. So I'm going to switch over now to a virtual machine so we can see a demo of the Microsoft Oracle Migration Assistant and what it looks like. So I'm going to get out of my slides here. And I'm going to move over to a virtual machine. So I'm hoping you guys can see right now. I believe you do. If you've never used a migration assistant, I'll give you a quick rundown of what the graphical interface, how it works. So we have here on this top panel, you can see here it says the Oracle Metadata Explorer, right? And then right below it is the SQL Server Metadata Explorer. So the tool is going to let us pick and choose what we want to move from Oracle to SQL. And let's say, for example, I can scroll down here and I have a schema called Warner that is loaded with some mock data that we're going to migrate to a SQL database called Warner as well. Now, to show you guys a few of the capabilities of the tool, for example, if I were to choose this countries table, it will give me the schema of the table here on this other panel. And if I just go on this tab at the top that says SQL, it actually gives me real T-SQL that is going to use to generate and create that table on the SQL Server side, right? So you can actually tweak these things manually if you want to alter it. I can actually also create a report if I want to see first if it's a, how many issues I might have or not have. So let's see if I can do that now. Okay, so you guys can see here I have the report open. That's the results of the conversion. And it tells me the type of objects that I found and how many were able to be converted. In this case, everything was able to be converted, so we get 100%. And you can see here objects by category as well. And we can see how many were able to be converted as well. If you have some warnings and some issues, you might want to navigate to them and you can see what those issues are and what the assistant is doing. So for example, here, I got a report that says there's a warning with this specific view is called EMP_details_view. So I can go on this and it goes and tells me what the issue is. So here we can see when it did the conversion, I get a warning message from the migration assistant that tells me there's an attribute that is on the Oracle view that's called with read only that does not have an equivalent on SQL Server. So the difference here is that when we look at the Oracle code, if you see Oracle has this this statement that you can mark a particular view as read-only, but SQL Server doesn't have that. Then you might say like, well, then I can't do this migration. But no, actually you can. The way that we make a view read-only in SQL Server is through the security of the view. It's not by marking it with a statement in this style. So that's why the migration assistant just continues. It translates a view. But at this point, it's up to you as the DBA or the expert to make a note and realize that this view was never meant for data manipulation. So you should make sure that there's no permissions on this view to actually insert, update, or delete any data, and there's only read permissions on this view, right? So again, obviously it's not all about the tool. As a DBA and as an expert, you need to apply your knowledge of the platforms to, like I said, come up with a detailed plan and path for a particular migration. Okay. So let me go back. Now that we see the reports capability, we can go back here. And if you see here, I have a SQL Server database already I created. It's called Warner here, and it's empty. It doesn't have anything on it. So if I go here to tables, you guys can see I don't have anything deployed. If I go to store procedures, I have nothing. So this is completely empty. And so we can try to do the conversion of the schema first. and then try to migrate the data. So I'm going to do that just to show you guys like the three phases of the report analysis, then convert the schema, and then finally we'll try to migrate the data. So in this case, the schema has been converted, and I look here, I can see, for example, the tables that it's going to try to create. Now, at this point, it has not applied the change to my actual SQL database, because what the Migration Assistant does is that it gives you a view here on the Metadata Explorer of what it's planning to do. And then you have the choice of staying with the Migration Assistant did, or you can tweak it on your own. So for example, if I go to countries, I can see that what the Migration Assistant is going to do. But if during the migration, let's say, I'm like, well, I actually would prefer, now that we're migrating, to get a little bit of leeway here in terms of my data type size. So you can, if you want, change some of these values before they get migrated to SQL. So you could change here, for example, the country name if you wanted to change the data type. Once you have exactly what you want, then you can just say you want to synchronize with the actual database, or you can save it as a script, or you can save it as a SQL Server data tools project, which is really cool as well. So in this case, for demo purposes, I'm just going to say that I want to synchronize it with the database, and it gives you a summary of all the things that is going to move. So in this case, I'm just going to say OK. All right, so that is done. Now I can refresh on Management Studio, and we can see what type of stuff if it migrated. So we can see now we do find the schema that we had, and for example, I believe there's a couple of stored procedures. So there we go. So the couple of stored procedures here, and you can, verify at this point that it is what you wanted. And if it isn't, then you can always go back and tweak it in the project. Now, finally, if you are happy with what you did, and you want to also try and see how easy it could be to migrate the data one-shot style, then it does come with that capability. You'll have to reconnect because it uses a separate connection for the actual data movement. So I'm connecting to both of them here, and let's see what happens. So now it does say starting data migration. And once it's done, it gives you, this is a very small schema, so obviously it happened really fast. But for every table, it does tell you how many rows it had, the table, how many rows it was able to migrate, how long it took, and the success rate. So here, for example, we see that everything was migrated, and I mean, that would be the best case every time that you would try to do this, of course. But a lot of times, you could say something like, okay, well, maybe we only had a 90% success rate, but that's already 90%. So we already, maybe we just have to develop an SSIS package and bring in the remaining 10% that we couldn't do just straight from the Migration Assistant. Or maybe there's an issue with that 10%, and it's data that we're not even interested on bringing forward with us. But again, the tool can really help you get off the ground and get an idea of what it will be easy to convert and what is not going to be easy to convert, and what will actually require manual effort or a little bit of development effort from the database perspective, right? At the same time, like I said before, we need to collaborate with application teams because there's a piece in the application as well. Obviously, if the application is submitting PL SQL directly, then that will have to be translated as well, or it will have to be moved into a store procedure, and then we can translate the store procedure. Okay, so I hope you guys got a good overview of the basic functionality of the tool. I do invite you to download it and play around with it on your own. It's absolutely free. You can just get it from Microsoft website. But we went to at least the three main use cases for the tool, which is to create the report, converting the schema, and then migrating the data one-time, one-shot style. Okay. All right. So a lot of people ask us, what do we do with estimations when we want to migrate something? How do we know that somebody is going to take X amount of time for an estimation, or it's going to take a lot longer. And really, every migration is very different. And the complexity depends on features that are used. And if there's schema and code complexity, it's really more important for that than the actual size of the database. You can have a 1 terabyte database, and let's use 1 terabyte because it's a number that still sounds kind of big, and have very little schema and code complexity and be able to migrate that seamlessly. And you could even just do it with the migration assistant and just leave the migration assistant running overnight, right? But you could do the other way around. You could have a database that is only, let's say, 25 gigabytes, but it uses a lot of advanced features. It has a very complex schema with complex types, with custom types, or it also has code complexity that goes beyond what the migration assistant can convert, right? So we do have projects. We have a project that was done in 1 week because it was a, very simple installation, not a lot of advanced features, not a lot of schema, not a lot of code complexity. And we've others that have taken, 12 months to be able to get all the way from that phase 1 that I showed you all the way to the phase 5. What we have found, though, is that when you put the two solutions side by side, the amount of savings that you'd get in the licensing and in the long-term supportability, they cover the cost of the SQL licensing, the hardware if it's an on-prem solution, or they cover for a long period of a cloud hosting piece, and they usually cover the manpower, man effort of the migration itself. Again, you have to think long-term, because if you commit to this, it might take, like, let's say I mentioned here 12 months to get there, but over the long term, the saving will cover that investment. So let's see some example cases of things that we have done at Pythian, which are very interesting. So this is a customer story of a media partner of ours that wanted to grow their data warehouse offering. So, use more advanced features, do more interesting BI to make it better for the business, to get better reports. And as they're growing their data warehouse, they need to start upgrading from standard to enterprise. And not only that, but some specific features that they wanted for their environment. So what happened here is we can see the solution comparison. So they were running with 16 cores of Enterprise Edition. They would need 16 cores of Enterprise Edition Oracle. They were interested in column store. They had a few replication requirements that they were looking at Golden Gate for. They were interested in supporting some spatial capabilities. They were interested in the multi-tenant feature to be able to move around some databases. They were interested in compression and partitioning. They felt confident that they would be better off if they could have the diagnostics and tuning tools. And at the end of the day, the licensing cost for Oracle with all these things included went beyond the $1 million mark. And when we did the same exact exercise with SQL Server, we found that it was about, the number there says $117,000, right? So we're talking a 10% change in licensing by going from from Oracle to SQL Server. And keep in mind, when they were doing that, not only was a 10% saving, not a 10%, 90% saving in licensing costs, but the features that they were all separately licensed for Oracle and more were already included on their SQL Server sticker price, right? We have another one, another case that was really interested. This is in the transportation industry, where our experts they used the migration assistant and SSIS to move from Oracle into an Azure SQL database. So this wasn't even into full-blown SQL Server; it was to Azure PaaS. And the interesting piece as well for this particular solution is that once it was migrated to Azure SQL database and optimized for that platform, not only was it cheaper to run, but it actually was also performing better than the original solution. So this is the solution comparison for that particular case. We had 8 cores of Oracle that were used in spatial and partitioning. And so when we add all that up, we had 306,000 US dollars, and that's just the Oracle licensing. So it does not include storage, it does not include hardware, it is not managed or anything, right? It's just literally the license, and that's all you get. And when we did the exercise for Azure SQL Database, and like I mentioned, on the Premium 2 tier of Azure SQL Database, they were already getting better performance. That was about $1,860 per month, right? So it would have taken 13 years to reach the equivalent of the one-time Oracle licensing. And we're talking about a product, Azure SQL Database in this case, already includes up to 1 terabyte of storage. It's fully managed by Microsoft, so it doesn't require you to make a hardware investment. It doesn't require patching. You don't have to think about how expensive it's going to be when it's time to renew the license, because it doesn't have such terms. It just has the monthly cost and so on. So you guys can see here again how it is a completely different return of investment when we think about what this client would have done if they continue to develop on this Oracle platform. That every time they need to renew the licensing, we're looking at $300,000 plus, as opposed to doing a project with Pythian, moving it to a fully managed platform such as Azure SQL Database, and like I said, with the cost of operating it in the cloud, it was the equivalent. 13 years would have taken or will take them before they reach the cost that they were about to do on just the one-time Oracle licensing cost. Okay. So that is it for the material for today in terms of tech and showing the migration assistant and sharing some of our stories. But before we go, I do want to mention that Pythian does have an Oracle to SQL offer. You can actually go to our website and you will find the information, or if you want to get for us to send you the information, feel free to shoot us an email at info@pythian.com. That's pythian.com, and we can send you the info for this offer. And basically what we do is our seasoned Oracle and SQL DBAs, they will use their migration approach that I mentioned earlier to analyze your Oracle database, and it's more or less a 1 week $10,000 cap assessment, and will help you create a migration path that we think you could use to migrate from Oracle to SQL Server. Okay, so the offer is out there. If you guys are interested in it, like I said, go to our website or shoot us an email. Finally, about Pythian, we are now 400 plus IT professionals around the world. We help companies adopt and manage disruptive technologies to compete better. We are very passionate about technology, and we're also very passionate about doing the right thing for our clients, and this is where this type of material is coming from. And like I said, we already managed over 11,000 systems, over 400 Pythian experts in 35 countries, and two millennia of knowledge gathered in the 19 years that we've been tracking issues and doing projects for all of our clients. Okay, so that is the end of the material for today. I am really glad that we were able to do this and that we were able to show everything we had. At this point, I don't know if we have any pending questions. If so, the moderators can just let me know. Okay, well, I'm not hearing anything from moderators, so I am going to assume that we don't have any outstanding questions. If there is something outstanding, or if you think of something later on today about, oh, I wish they would have talked a little bit about X, Y, or Z, or I just thought of something I wish I could have asked in the webinar, do not worry. Just shoot us a question at info, again, info@pythian.com, and we will get back to you. So I hope this was valuable for everybody to get a good idea of how these projects are approached and the tools that are available for it. And I also hope you have a great rest of the day wherever you are in the world. Thanks for joining us, and until next time.